right, class, section 6.4 is all about equations with rational expressions. So, friendly reminder that a rational function is a function of the form p of x over q of x, where p of x and q of x are polynomial functions. Q of x doesn't equal 0. This is what we call a rational function. Remember that q of x doesn't equal 0 because we can never divide by 0. So when I'm working with rational equations, I need to make sure that I'm excluding from my domain the values that would make our domains of each rational function equal to 0. So in order to do that, to find the domain of a rational equation, the first thing I have to do is set each of the domains equal to 0 and solve. So for problems 1 and 2, I'm just asking you to state the domain. So if I let x equal 0, 2 doesn't equal 0, so I can ignore that. 2 of x equals 0, so x equals 0 is the only value that's going to be excluded from my domain. I can write my domain in set notation or in interval notation. I do not care which you do, as long as you do it correctly, okay, and understand what you're doing. So in set notation, I would have all x's such that x doesn't equal 0. Or in interval notation, I have all the numbers from negative infinity to 0, but then we hop over 0 because 0 is not included, and we union that with 0 all the way to positive infinity. For this second equation, I have 2 over x minus 3 minus 3 over x plus 3 equals 12 over x squared minus 9. So I have to set each of those denominators equal to 0. On the left here, I add 3 to both sides, so I get x equals 3. Next, I subtract 3 from both sides. I get x equals negative 3. I have to factor x squared minus 9. Luckily, I know from everything we learned in chapters 5 and some of 8 that this is a difference of squares. So this becomes x minus 3 times x plus 3. So I would set each of those factors separately equal to 0. And I see that x equals 3 and x equals negative 3. So I have x values of 3 and negative 3 excluded from my domain. So in set notation, we'll do that over here. That would be x such that x doesn't equal 3 or negative 3. In interval notation, think about it in terms of a number line and what values we're skipping over. I'm going to skip over negative 3, and I'm going to skip over positive 3. Those are the only two values not included. The reason I drew it on a number line is because I think it allows you to envision interval notation a little bit better. So here you see I have negative infinity all the way to negative 3. Union that with from negative 3 to positive 3, and then union that with 3 to infinity. So that would be the domain of these two rational equations. So what we're going to do in this chapter is we're going to be solving rational equations. So the first step is to find the domain of our variable. The second step is going to be to multiply both sides by the least common denominator, as that will eliminate the denominators of our fractions, making this a lot easier to work with. Then we need to solve and check that our solution is indeed in our domain. So why don't we go ahead and do some of that. So first, we already found the domain of this function, right? We did that like a minute ago. Our domain is x such that x doesn't equal 0. The next thing I need to do is determine my LCD. So what's the LCD of x, 2, and 2x? Well, in order to remember I used to make this table. You don't have to make this table if you see what the LCD is, but if you don't, it can be helpful. Why did I say that so sing-songy? Okay, so in order to be divisible by x, I need a factor of x. In order to be divisible by 2, I need a factor of 2. And in order to be divisible by 2x, I need a factor of x and a factor of 2. So my least common denominator is going to be 2x. I multiply both sides by 2x. 2x times 2 gives me 4x over x. 2x times 3 gives me 6x over 2. 7 times 2x gives me 14x over 2x. I can then simplify these fractions. 4x divided by x is just going to be 4. 6x divided by 2, that's going to be 3x. And 14x divided by 2x, that's just going to be 7. So now I can go ahead and subtract 4 from both sides. Again, we want to isolate our variable, right? We've got an equation in a single variable. That gives me negative 3x equals 3. So I divide both sides by negative 3, and I find that x equals negative 1. Next, I need to check that that solution is in my domain. Well, I know my domain excludes everything, excludes nothing except 0. And negative 1 isn't 0, so we have a solution.